Okay, linear transformation C25 is a verification problem. We want to verify that this particular linear transformation is indeed a linear transformation according to the theorems. So again, it takes a 3-column vector and turns it into a 2-column vector, or a 2-row vector, x1, 2, 3 gets turned into this. So to check it, there's really 2 ways to verify that it's a linear transformation. One of them is sort of cheaty, and that's just to say, because Tx can be expressed as some matrix times x, that makes it by definition, or not by definition, but there's a theorem that supports it. It's MBLT. And so, that's one way of sort of handling this problem really quickly, is to just say, hey, if the linear transformation actually performs the same as a matrix multiplication, in this case it does. We can see the matrix in there, times x1, 2, 3. But let's verify it sort of by the brute force method, by checking this. So what we want to do is look at t of u plus v and see if that's the same as t of u plus t of v. That's the first condition. So let's check that. So t of u plus v is going to replace x1, 2, and 3 by u1 and v1, u2 and v2 all the way up. So we're going to have t, and then the new argument's going to be u1 plus v1, u2 plus v2, and u3 plus v3. And what we're going to do is run that through the process. So this is what that looks like. So that's going to be 2 times the quantity u1 plus v1 minus the quantity u2 plus v2 plus 5 times u3 plus v3. And then the second row is going to be the same, minus 4 times u1 plus v1 plus 2 times u2 plus v2, and then finally minus 10 times u3 plus v3. Well, if I take this particular matrix and I sort of manipulate some of its elements, I can basically turn it into 2u1 minus u2 plus 5u3, and then underneath it minus 4u1 plus 2u2 minus 10u3. So that's one matrix, and then that matrix is added to a second one. And again, we did this just by basically factoring. And the second one is 2v1 minus v2 plus 5v3, and on the bottom it's minus 4v1 plus 2v2 minus 10v3. And if you look closely, this is just the linear transformation applied to u, and this is the linear transformation applied to v. So there's our verification. This means it's the same as tu plus tv. And we knew that was going to work out just because of MBLT, but it's nice to sort of demonstrate it sometimes. Well, that's condition 1. Condition 2 is a little easier, and that's that t of alpha u is the same as alpha of tu. In other words, the multiplication by a scalar coefficient should be commutative. So first, let's calculate t of alpha u, and of course that would be just 2 alpha u1 minus alpha u2 plus 5 alpha u3. And then the lower line would be negative 4 alpha u1 plus 2 alpha u2 minus 10 alpha u3. So that would be the solution. And then you can see everything has an alpha in it, so we can just factor that out and say it's the same as alpha times the matrix 2u1 minus u2 plus 5u3. And the bottom line is minus 4u1 plus 2u2 minus 10u3, which you can see is the same as alpha times the linear transformation of tu. And so this verifies it. In other words, this is a linear transformation because it satisfies both conditions, which we knew already from MBLT. But this is sort of the old school approach.